Okay, so here we go again. We are going to continue with the chapter 4 for semester 1, which is state of matter, solid, liquid, and gas. And today we are going to discuss for section C, which is the essay questions for this chapter. So with annexation, let's begin our lesson. Ammonia gas is a commonly synthesized large-scale via Haber process. It can be synthesized in laboratory by reacting ammonium salt with a base. When ammonium nitrate is mixed with magnesium hydroxide and heated strongly, total of 500 centimeter cube of dry ammonia gas were collected in a container at the pressure 101 kilopascal and 25 degrees Celsius. Calculate the minimum mass of magnesium hydroxide is used for these reactions. Okay, so here you can see that there are no equations. So in other words, you have to write your own balance equation. So the equation between ammonium nitrate when mixed with magnesium hydroxide is as following: MgOH2 plus 2NH4NO3 give MgNO32 plus 2NH3 plus 2H2O. Okay, so after you balance only, then you can start to calculate. So you use PV equals to nRT to calculate the mass or the mole of the ammonia gas. Okay, so you have the pressure, you have the volume, you have the condition R and T. So you just need to calculate the number of mole. So after applying them, so don't forget that substitute as exactly given to you in the question, and be careful with the kilopascal. So kilo is times 10 power of 3, also substituted inside your questions there. So at the end of the day, your number of mole calculated is to be 0.0204 mole of gas of ammonia form. Okay, so in here, only the ammonia is a gas here. Then you have to stoichiometrically compare the mole of ammonia to the mole of magnesium hydroxide. So it's 2 to 1. So from here, the mole of magnesium hydroxide will be divided by 2. So you get 0.0102. And then you multiply with the mass of, or RMM of the magnesium hydroxide. So at the end of the day, you get 0.954 gram in 3 significant figure. So that is how you are going to solve for number 1A. So immediately we goes to 1B. When ammonia gas is heated, it tends to decompose to form back nitrogen and hydrogen gas according to the equation. So 2NH3 give N2 plus 3H2. So when 0.100 mole of ammonia is heated to 537 degrees Celsius in the 5 decimeter cube of flask, a pressure form is 150 kilopascal. So what is the partial pressure of the hydrogen gas in the mixture, in the flask here? So in here, you have to first calculate what is the total pressure, what is the total mole when 0.1 mole of ammonia is heated. So because 0.100 is the initial mole of ammonia. So after heated, then the mole become mixture already. So when it become mixture, that is where you have to first find the total mole of the gases form. So first of all, you use the ideal gas equation, PV equals to nRT. So 101 times 10 power of 3 times 5.0 times 10 power of negative 3 is equals to n times 8.31 times 525 plus 273. So at the end of the day, you get your mole of the total gas is 0.1128 mole. So then you have to rewrite the equation. 2 ammonia give N2 plus 3H2, and you use the equilibrium principle to deduce the mole of the hydrogen gas form in here. Okay, so initially you have 0.100 mole of gas. So 2 ammonia give 1 nitrogen plus 3 hydrogen. So after dissociated, you dissociated 1 nitrogen plus 3 hydrogen. So the stoichiometry is 2 to 1 to 3. So in here, ammonia minus 2x, or simply minus x, nitrogen plus half x, hydrogen plus 3 over 2x. So the total mole of the gases in here will be 0.100 minus x plus half x plus 3 over 2x. So at the end of the day, you need to find out what is your mole of x. So mole of x at the end of the day is 0.0128 mole. Then you use to calculate the mole of the hydrogen. So the mole of the hydrogen form is 0.0128 times 3 divided by 2. So you get 0.0192 mole. So 0.0192 mole, you multiply with the total mole of gases in here, which is 0.872 from nitrogen, 0.0064, which is from ammonia, and finally 0.192, which is for hydrogen, times 150 kilopascal. So at the end of the day, your partial pressure of the hydrogen is 10.1 kilopascal in here. So this is how you are going to calculate for the partial pressure of the hydrogens in here. Okay, so hopefully you'll be able to understand the methods used in here. It's quite common in STPM, so you must be able to know how to calculate this. Last but not least, C, explain the negative deviation caused by ammonia as the pressure increase. So you have to explain what causes the negative deviation. The negative deviation is caused because you have the attraction forces, and specifically for ammonia, it has hydrogen bond. Okay, so as a result, PV over RT is lesser than 1. Okay, so attraction forces is strong. So that is why partial pressure exerted is lesser than expected. So when you have a pressure lesser than expected, so that is why it gives a negative deviations. Okay, so my advice to you, you should always have all these points. PV over RT is lesser than 1. Pressure exerted is lesser than expected since particles collide less frequently with the wall of the container, as ammonia has attraction forces, or you said ammonia has strong hydrogen bond. Okay, so therefore a negative deviation. So that is how the sequence you should be writing whenever you are trying to explain a negative deviations. Okay. Okay, so that is all for essay question number 1. Immediately we move to essay question number 2. Water, ethanol, and ether are solvent which is usually used in a chemical laboratory. A graph of saturated vapor pressure against temperature for the water, ethanol, and ether are shown below. So define the saturated vapor pressure. So what is a saturated vapor pressure? Saturated vapor pressure is the vapor pressure exerted by the collision of the molecule with the wall of container. Because of the word saturated, this one also you have to mention in a closed system. Okay, so because the question mentioned saturated, so you also have to mention this statement where the rate of vaporization is in equilibrium with the rate of condensation. Okay, so that is how you are going to describe for the saturated vapor pressure. Okay, so this is how you are going to deduce. And then using the bonding and structure, explain the volatility of water, ethanol, and ether under atmospheric pressure. So as you can see in here, the 45 is for ether, 78 is for ethanol, and 100 is for water. So why is it that they exhibit such different structure? So you have to explain by using the bond and structure lah. So in here, you have to know by yourself that both water and ethanols are held by hydrogen bond. Okay, so volatility increase from water. Water has the lowest volatility, followed by ethanol, and ether has the highest volatility. So this is due to vapor pressure of the molecule are higher for ether, as ether is a simple covalent molecule held by weak van der Waals forces, whereas ethanol and water are held by strong hydrogen bond. So water has a higher vapor pressure, water has a lower volatility compared to ethanol because water has greater number of hydrogen bond compared to ethanol. If you are worried, you might also want to add that statement inside your essay answer. Okay. And finally, number 3, using kinetic theory, explain the changes of vapor pressure on ethanol as temperature increase. So you have to explain how does the temperature increase affect the vapor pressure. So this will have to do with temperature increase, the kinetic energy increase, particles collide more frequently with the wall of container, produce more vapor. So that is the point that you must always try your best to know or to explain about the effect of temperature towards the vapor pressure. Okay, so hydrogen bond in water is stronger than ethanol. Okay, just now that one, sorry. Okay, and then number 3, vapor pressure is higher at a higher temperature. Why? Because ethanol molecule has higher energy or move faster or gain more energy at a higher temperature. As a result, molecule collide more frequently with the wall of the container with greater strength, therefore produces more vapor pressure in here. So that is why vapor pressure increase with the temperature. So that is for number A. And then we have number B. Carbon exists naturally as diamond and graphite. State and explain the relationship between diamond and graphite. So both of them are allotropes, where they are elements with the same state of matter, but exist in different structure, okay, or different physical form. Then number 2, using suitable diagram, compare the structure between diamond and graphite. So diamond is sp3 hybridized structure. Okay, so this is the structure of the diamond. Inside here, you have to try your best to explain to draw out the hexagonal shapes in here. So where are the hexagonal shape? If you look carefully, this is the first hexagonal shape inside the diamond. Okay, so where is the second hexagonal shape? The second hexagonal shape is here. Do you notice carefully? So this is the hexagonal shape. So you have to draw these two hexagonal shape in order to score the 2 marks inside the diamond. As for the graphite, you have to draw the hexagon layer structure in here. Okay, where each of the carbon is sp2 hybridized. Okay, if you notice carefully. Okay, so you have to draw 2 layers in here. So draw 2 layer hexagon shape, and then the second mark goes to label the weak van der Waals forces inside the graphite here. Okay, and only then you'll be able to score the 2 marks for the structure for graphite in here. Okay, so with that, that is how you are going to describe the structure of diamond and graphite. Okay, with that, that is for number 2. Immediately we move to question number 3. Glucose is completely miscible with water. Sketch a level vapor pressure, temperature graph for pure water and aqueous solution of the glucose at the same axis. So vapor pressure temperature graph. So this is this one. So the solid line in here is representing water. You must draw the negative gradient in here, label as solid, liquid, gas. Okay, whereas the dotted line is glucose, aqueous glucose. Okay, so label you have to label, of course. So inside my notes here, I didn't label. So I hope that okay, I label for you. Sorry for that. So this is for pure water. This is for glucose aqueous solutions. Okay, so you have to label both of them. Okay, so that is how you are going to score the 4 marks inside here. Okay. Okay, so we move on to the next question. So based on the diagram you have drawn in 1 above, explain qualitatively the effects on the vapor pressure and boiling point of the water when glucose dissolve in it, and the freezing point of water when the glucose dissolve in it. So each of them will have marks eventually. So how are you going to explain this? So vapor pressure and the boiling point of water is greater than expected. Why? Because after adding the glucose, the triple point will be lower. Okay, hence it decreases the vapor pressure. So when your vapor pressure decreases, the boiling point will increase as the glucose molecule occupy the space between water. Okay, especially on the surface of the water. Okay, so making the water to become less easily to vaporize, as glucose is less volatile than water. Hence, this will increase the boiling point of the water when you have glucose inside the substance. So that is how you are going to explain the effect of the glucose towards the vapor pressure and also the boiling point of water. As for the freezing point of water, so it is also caused by the same reason, the triple point lower. So when triple point lower, the solute cause the disorder inside the solvent. Okay, so when the solute cause disorder inside the solvent, it requires more energy to remove disorder. So as a result, the melting point decreased more than expected. Okay, so that is how you are going to describe the freezing point of the or the melting point of the aqueous glucose in here that causes the melting point or freezing point decrease. Okay. Okay, and then for C, outline how would you separate aqueous solution inside into its components. So you have to use distillation processes where you boil the water at 100 degrees Celsius and it vaporize away. So the remaining substance in here is then dried. Okay, it's crystallized under saturated condition. So that is how you will separate glucose from water. Okay, so with that, that is how you answer for essay question number 3. Then we have essay question number 4. Carbon dioxide is a gas at 25 degrees Celsius, 1.0 atmosphere. its triple point is 56.4 degrees Celsius and 5.11 atmosphere, and its critical point is 31.1 degrees Celsius and 73 atmosphere. A. Sketch and label the phase diagram of carbon dioxide. Now, if you notice carefully, these questions, everything is given to you already. So you have to make sure that you draw the diagram and label everything completely, including the solid, liquid, and gas. Where are the triple point? Where is this critical point? So make sure that you label all completely as shown to you in the diagrams in here. Okay. B. Carbon dioxide can be liquefied under suitable conditions using kinetic theory of gases. Explain the liquefaction of the gaseous carbon dioxide at the increasing pressure. Now, you look carefully at the way of how the question asks. The question says carbon dioxide can be liquefied under suitable conditions. So liquefy means that how does the carbon dioxide gas become liquid? So, however, the question does not tell you what process is that, isn't it? So telling you the process from gas to become liquid is the key that helps you to solve how does the gaseous carbon dioxide be liquefied when you increase the pressure. Okay, so in here, gas liquefy to become liquid under increasing pressure. So you have to explain that. So when the gas is increasing pressure, so the pressure increase the distance, so the particles become closer. So when the particles become closer, this will make the attraction forces between the particles and hence cause the gas to undergo condensation reaction. So the first keyword in here is you have to mention that carbon dioxide gas undergoes condensation reactions. Sorry for that. Okay, you have to undergo condensation reaction to become liquid. Since attraction forces or intermolecular forces or weak van der Waals forces increase as the molecule become closer or molecule cannot move freely. So that is the reason why. And finally, particles become closer and the volume decrease also can. Okay, so that is why the gas are able to liquefy to become liquid. So that is how you answer for number 4B. Carbon dioxide gas formed from fire extinguisher is used to put out small fire. A white fog is observed when carbon dioxide released from the fire extinguisher. Number 1, explain the formation of white fog. Okay, so the white fog, as I already mentioned previously, so the white fog is formed as a result of where this carbon dioxide in the liquid form, it condenses. Okay, it vaporizes. So when it vaporizes, it absorbs the heat from the surrounding. So when it absorbs the heat from the surrounding becomes cool. When the surrounding becomes cool, the water vapor from the surrounding undergoes condensation. That means from water vapor back to become liquid. And that water vapor becoming liquid is the one that you observe as the white fog in here. Okay. So in here, the two keywords that you should mention is when carbon dioxide undergoes this vaporization, it absorbs heat from the surrounding. So as a result, temperature decrease and the carbon dioxide cools the air. So water vapor from the surrounding condense the water vapor to form the fog. Okay, so that is how you explain the formation of white fog. Number 2, fire extinguisher cylinder has the internal volume 2.00 mole per decimeter cube and containing of carbon dioxide. Calculate the pressure of the carbon dioxide in the condition at 25 degrees Celsius. So you have to use PV equals to nRT, and then you substitute the volume of the vessel is 1.8 times decimeter cube. So sorry, 1.8 times 10 power of 3 kilogram. So kilogram you have to convert to gram, so that is why you have to times 10 power of 3. So divided by the molar mass of carbon dioxide, which is 44. So divided by the volume, which is 2.00 decimeter cube. So decimeter cube you have to convert to become meter cube. That is why you have times 10 power of negative 3. Okay, and when you substitute the volume, please always bear in mind, substitute as exactly given to you in the question. If the question give you 2.00, substitute 2.00. If the question give you 1.80 kilogram, substitute at 1.80. Okay, so after you press your calculator, you can calculate your pressure is 5.07 times 10 power 4 kilopascal or 5.07 times 10 power 7 pascal. So what I'm trying to tell you in here is your answer may not necessarily must be in kilopascal. You can describe it in pascal. The key significant in here is you must have 3 significant figures because all the values inside the question has 3 significant figures. So you have to be careful on that. So that is how you solve for number 2. And then number 3, the actual pressure of the fire extinguisher is 2.54 times 10 power 4 kilopascal under similar condition as C2. Explain the difference between actual pressure and the calculated value. Now, this calculated value is by presuming that if carbon dioxide is an ideal gas, but we know for a fact that it won't be ideal, okay? So that is why you have to explain from here. So if you compare, this is the vapor, this is the pressure for ideal gas, and this is the actual pressure. So the actual pressure is lower than the ideal pressure. So why is it that the actual pressure is lower than the ideal pressure? Then you have to back from the beginning, which is explaining the deviations of the gases. So in here, it is a negatively divided gas, okay? So how are you going to explain? So pressure produced is lesser than theoretical. Why? Because carbon dioxide behaves as a real gas or non-ideal gas. Therefore, attraction forces, because attraction forces presence or van der Waals forces presence or weak intermolecular forces presence. Okay. Therefore, pressure exert lesser than expected, or pressure particles collide less frequently with the wall of the container, or you say the pressure is reduced also can. Okay, so therefore, and then you also want to write PV over RT is lesser than 1. Okay, and therefore exhibited a negative deviation. Okay, so that is generally how you are going to explain all these. So you must be very you must know what are the points that you have to use whenever you whenever you experience or encounter such questions. Okay, immediately we go to essay question number 5. So name with reason A, a gas behaves almost ideally under room temperature, and a gas that deviates far from ideality under room temperature. So the gas that behaves almost ideally under room temperature, as we already mentioned, is hydrogen and helium. Okay, so why? Because they are light gas, okay, and has no intermolecular forces. Okay. As for the gas that deviate far from the ideal behavior, any heavy gases, for example, carbon dioxide, ammonia, methane, chlorine, okay, so all those gases that are divided far from the ideality. Why? Because they have a large mass, they have a significant intermolecular forces, they have a significant volume. Okay, so all of them are simple covalent molecules held by weak van der Waals forces. Therefore, they have attraction forces. So that is how you are going to explain the gas that behave almost ideally under room temperature pressure and a gas that deviate far from the ideality. Okay. B, the following result were obtained from a gas at 273 degrees Kelvin. So pressure 0.25, density 0.18. Pressure 0.5, density 0.36. Pressure 0.75, density 0.54, and pressure 1 atmosphere, density 0.72. From the information, determine the relative molecular mass in here. So you can use any pair to calculate MR is equals to DRT over P. So MR is 1.00. So let's say I use this 1 atmosphere. Okay, so 1.00 times 10 power negative 3. So which is the density of the gases. Okay, and then time 8.31 times 273 divided by 1.0 times 10 power times 1.01 times 10 power 5. Because this one is in atmosphere, so atmosphere you have to convert to become Pascal. So that is why you have this. And the molecular mass is 16.1. C, determine the relative molecular mass of ethanoic acid that was carried out at the various temperature and given the value of the range between 60 and 120. Explain the above observation. So in here, relative molecular mass of the ethanoic acid is 60 if you calculate accordingly. However, ethanoic acid exists as a dimer under room temperature pressure. Why? Because it uses hydrogen bonds to form a dimer in between them. So this is the structure. So as a result, the molecular mass is greater than expected. However, when molecular mass, when this molecule was heated, hydrogen bond is broken. So that is why you form back the monomer of the CH3COH. Okay, so I know the such questions is actually very hard to explain, and students must know by themselves that why is it that the molecular mass of the ethanoic acid is double. So this is actually covered when we study hydrogen bonds inside chapter 3. So you might want to look back about how this ethanoic acid form dimer under room temperature pressure. Okay. Okay, so with this, that is all for the essay questions that I've already prepared for you. So hopefully you'll be able to understand better on the technique on how to answer the essay question. So with that, that is all for our lesson today. So see you all in our next chapter, which is chapter 5. So goodbye.